Hello students, today we will be finding out the electric field on the equatorial line of an electric dipole. So we already have an electric dipole set up here, which is nothing but a pair of equal and opposite charges which is separated by a finite distance. Now on the equilateral line, because of these two charges, let us find, or we need to find, the electric field. So equilateral line, it is basically nothing but the perpendicular bisector. So equilateral line is nothing but the perpendicular bisector of a dipole. So on this equilateral line, let us consider a point P. And at this point, let us find the electric field. Now, so let us consider a point P from the center of our dipole and let that distance be R. Now let's join the points A, P, and the points P, B. Now if we look into the Pythagoras theorem, we know Pythagoras theorem is nothing but hypo square is equal to perpendicular square plus base square. So our hypo is nothing but a p square. If we consider this right angle triangle, our perpendicular, the distance perpendicular is r square, and our base is, the full is 2a, the half of this is a, so it will be nothing but a square plus r square plus a square. It's the same thing. Now if I remove the square from this side, I would have ab is equal to root over of a square plus r square. So I have a value which is the distance from a to b to be a square plus r square. Likewise, it will be same for the other side as well. Now let us find the electric field at point P due to point P due to plus Q charge. So whenever we find the electric field at any point, we normally consider a test charge to be present. So suppose we have a test charge here which is obviously positive in nature. So because of this plus Q and the test charge which is positive in nature, positive and positive will eventually repel one another. So because of that repulsion, the electric field line direction would look something like this, which is your E electric field experienced because of your plus Q charge. Likewise, I have a minus Q charge, I have a test charge here. Minus and plus, they normally attract one another, so the electric field direction would look something like this, which is E minus of Q. Now we will find the magnitude of these two charges. So let us assume that this angle to be theta, and since the length of this triangle is equal, so we can say that this is an isosceles triangle, so the other angle will also be theta. Now if we draw a component here, suppose I drew a component here, so because of alternate interior angles, this will also be theta, right? So this is basically our cos theta component, so we can write it as E plus Q cos theta and E minus Q cos theta. We also have our sin theta component, but since they are equal and opposite to one another, it gets cancelled out, so I will not be drawing that. Now the magnitude of E plus Q due to the magnitude of E plus Q due to the plus Q charge is given by, at point A, can be written as E plus Q is equal to 1 by 4 pi epsilon naught Q divided by root over of A square plus R square whole square. So square and square get cancelled out. We have an equation which is E plus q 1 by 4 pi epsilon naught q divided by a square plus r square, which is equation number 1. Likewise, the magnitude for E minus q due to minus q charge can be written as E minus q is equal to 1 by 4 pi epsilon naught q divided by, since the distance for this angle is also a square plus r square whole square. So I have my equation, which is 1 by 4 pi epsilon naught q divided by a square plus r square, equation number 2. Now if you look carefully, e plus q and e minus q, they are equal, the same thing, right? Because they have the same magnitude. So coming down, now in order to find the total electric field E vector, since E plus Q cos theta and E minus Q cos theta are equal and directed towards the same direction, we will sum them up. So our equation will look something like E vector is equal to E minus Q cos theta plus E plus Q cos theta. Since we have already mentioned that earlier, they have the same magnitude, so this equation I can write it as E is equal to 2 times of E plus Q or minus Q. It is the same thing since they have the same magnitude. After which I will just be substituting the values to E minus Q, which is 1 by, if I put the value of E plus Q also, it would be the same. There will be no changes in this equation. Into, we have a cos theta value, and we know that cos is nothing but your base by hypo, and my base is nothing but a, and my hypo is root over a square plus r square, so which I will be substituting here, a divided by root over of a square plus r square. So from this equation I can see that I'm familiar with this 2aq, which is nothing but the dipole moment, p vector, which is nothing but your dipole moment to aq. So I can write down p divided by 4 pi epsilon naught. Now if we look here, a square plus r square, this is power 1. Likewise, a square plus r square root over, I can write it down as this. So we know that if the base is the same, we can add up the powers. So when we simplify that, we get a square plus r square 3 by 2, which is your E equatorial. Now at a larger distance, r is very much greater than a, so this equation reduces to E is equal, so our final equation will look something like E equatorial is equal to P divided by 4 pi epsilon naught. And if we look here, if we consider r to be at a larger distance, r is very much greater than a, so a we can basically neglect. We're left with r squared 3 by 2, so when 2 and 2 gets cancelled, we're left with r cubed. So this is our final equation.